Compare the features of f of x and g of x. F of x is 1/2 to the x power plus 1, and g of x is this graph represented on the plane here. So let's think about some of the ways that we can compare functions. We can talk about transformations. Did it move up, down, left, or right? We can think about domain and range. We got domain, range. We can think about whether they're discrete or continuous. We can also think about whether they have intervals of increase or decrease. Okay, let's start with transformations. I'm actually going to graph f of x equals 1/2 to the x first, so I can see it. Let's do x equals 1/2 to the x power. Now if I graph the same thing, but I do (1/2 to the x power plus 1, that's going to move the graph up 1. And here, since I have a value at 0, -2, let's put that here, 0, -2, I wonder if this would be, I'll do h of x this time, 1/2 to the x power minus 2. Aha. There is my point. Oh, that's supposed to be a minus. Oh, so maybe that's -3 then. Let's check this out. Let's try -3. Ah, there we go. Yes, that makes sense because it should have a value here at 0, 1. So -3 would make it go down to 0, -2. All right, so start with translations. F of x is a translation of this parent function. This is the parent function right here. This one has been translated up 1. Say translation of the parent function up 1, g of x is down 3. Okay, for domain, so domain for both f of x and g of x is actually going to be all real numbers, because we can take any number and raise 1/2 to that power and then add 1 to it. So our domain for both will be from -infinity to +infinity. Our range, though, for f of x is 1/2 x plus 1. Our normal range for this exponential function would be, it would be bigger than 0. Adding 1 to it means it's going to be bigger than 1. So I'm going to be able to have y values that start at 1 and go up. So I'm going to have, I'll do a different color for this. For f of x, it's going to be from 1 to +infinity. But for g of x, my smallest value is actually here at -3. It's going to be bigger than -3. Is -3 to infinity. All right, now whether these are discrete or continuous, these are both continuous. They are connected. And there's values in between the whole numbers or integers. And then intervals of increase or decrease. Well, both of these, because we're raising it to, because we're using 1/2 to the x power, each, as x gets bigger, our f of x or our g of x is getting smaller by factors of 1/2. So both of these are going to be decreasing over the entire domain. Both decrease for the entire domain.